Hello, and welcome back to Advancing Spark, where today we're having a bit of a dig into vector databases. And you might be like, oh, that's an old thing. We've been doing that a load with all this RAG implementations and things. But the new thing is we've now got the ability to build vector databases or vector search indexes directly inside of Databricks. So it's a fairly new feature, currently in public preview. But you can build a vector index directly inside of Databricks. So if you're trying to do a retrieval augmented generation, this is all to do with large language models, all to do with building out your own GenAI kind of model. If you're trying to build an application that doesn't hallucinate, that has some context, you're feeding it some information from your data at runtime so it can answer questions more accurately, and you want to build that entirely within Databricks rather than stitching things together, that's what we can now do. So today we're going to be running through essentially what it looks like, some limitations, what the requirements are, all of that good stuff. So you can get started with vector search indexes within inside Databricks. That's the plan. As usual, if you're new around here, don't forget to like and subscribe. And shockingly enough, because as most of you know, I am very much on the engineering side of the fence, I'm not doing this alone. So happy to say, welcome back, Gavi.
Hi, Si. Hello.
How's it going?
How are you doing?
I'm good. It's about down time we had you back on the show.
I know, thanks. Yeah, exactly. I've been busy. I've been flat out. But yeah, it's good to be back. It's good to be talking about all AI and Gen AI stuff, especially on Databricks as well. So it's really good to be back.
So come on, what are we talking about? Why are we talking about vector search? What's the point?
Right, cool. Very good question, right? Vector search is probably the fundamental blocks in terms of if you were going to do a RAG type pattern implementation, you need a vector search. In the past, we've spoken about AI search. We've spoken about all the different vector databases out there. But today, what we're going to be looking at is Databricks vector search.
Okay, cool. And it's new, public preview in a few locations, right?
It is, yes. So hopefully I'm sharing my screen and you can see my screen. But yeah, It is public preview. It's pretty new. Only in selective regions as well. We've got the regions up on the screen. So this is a documentation that's available in Azure. It talks about what Databricks vector search is all about, what kind of algorithm that's really driving the Databricks vector search. It uses the hierarchical navigable small wall algorithm, which is pretty cool. There's a whole kind of research out there on the internet if people are interested to understand how that works. It also uses the L2 distance. But you can use cosine similarity. So for people out there who's very, very used to vector databases that understand there's different kind of search algorithms, there's cosine similarity, there's L2 distance, and a whole host of other kind of algorithms. But the Databricks vector search is looking at L2. You can do cosine similarity. You've got to normalize your data. Lots of cool information out here. It also has got a nice diagram in terms of how it works within Databricks.
And there's one key feature in there which I need to call out as obviously as a massive Sparky Databricksy nerd. The fact that this runs on a Delta table, so you're not having to pick it up and chunk it and throw it on. These are things you can create directly on a Delta table inside Unity Catalog, and it's plumbed into your existing ecosystem of stuff.
Exactly. Yes.
Am I stealing all your thunder?
You are stealing my thunder, but perhaps I've got another question for you. Why is that so beneficial for enterprises or companies out there, Si?
Why is Delta? Just watch the rest of our YouTube channel. I mean, these days it's the standard of how everyone's storing their data. So if you build a data platform, whichever data platform you're using, most of them are going the lakehouse route of having separation of storage and compute and some kind of modern file format, Delta being the default if you're using Spark. So like all of our clients, all of their data is stored as Delta tables. So being able to just hook this stuff up directly rather than needing to pull it out, change a format, put that bit over there for that purpose and put that over there for that purpose, it's trying to make a universal platform. So makes sense.
Yeah, you said something that piqued my ears, to be honest with you. Unity Catalog. That was one thing that I needed to get this set up, get Unity Catalog working. Wasn't easy. I had to come to you for help. I had to go to other data engineers for help. But I see a huge benefit, right, in terms of our customers using Unity Catalog. They can see loads of different documentations that spread across their enterprise. That's a huge, huge advantage.
We do keep coming across clients who are like, yeah, we're not using Unity yet. And we're like, why? Almost every new feature that comes out in Databricks, you need Unity for. So get it done. Be fine.
So yeah, Databricks vector search, you need a Unity Catalog enabled workspace. You need serverless compute enabled as well, because what that allows you to do is hook on to other models outside of Databricks. So you need that enabled. You need source data. Your source data must have changed data feed enabled. Now that was new to me. I've never ever used that before, but yeah, that was cool. And yeah,
So it's a
other
very
kind of
engineering
requirements.
thing. It's very
Right.
much a Delta feature. It's something we use a lot in terms of Delta. If people actually sort of constantly updating a Delta table, and you wanted to keep all the we updated that record and only that record and be able to hook things up, it makes so much sense. But it's just such a specific feature that only like nerdy data engineers would be like, oh yeah, I know what that is. That's fine.
Yeah, I've never seen that before, but that was something that as you go, we'll show you in a bit how when you set up your vector indexes, that comes up as a prompt. If you don't have that enabled, it will shout at you. But that was easy enough. And what you need is a couple of things, right? You need create table privileges and personal access tokens enabled.
All thoroughly achievable.
Yeah, absolutely. Absolutely. So now I'm going to show you the fun part, how easy it is to set up. Once you get Unity Catalog enabled, once you have all those requirements ticked off, how easy it is to get a vector index going.
All right, let's see.
Right, you ready? Right,
Always.
So here, what I'm showing is our Catalog Explorer. And what it shows is all the different catalogs that's available in your business or enterprise. Now I've set up a catalog just for myself to play around with vector index, and it's called GenAI Sandbox. Now within this sandbox, I've got a couple of tables, all Delta tables as well. Now I've got a different tables here because I was playing around with it, and what I've done is actually gone ahead and index a couple of the tables, and I'm going to just show you how easy it is with a number of clicks as well. So let's look at the chocolate data set. Interesting data set. The reason why I chose a chocolate data set, it's got a huge column based on text, based on get reviews from people based on where they bought chocolates from, how good it tastes, or how horrible it is, or how bitter and sour and sweet. So I thought, right, let's give this a go. Now,
And you thought it'd make a pretty sweet example. Carry on.
Very sweet example. Right. So if you've got a Delta table and you're wanting to do a RAG implementation, it's very simple. All you do is click on this, click on your three buttons up here, and you can all you do is create a search vector search index, right? And what happens is you get this UI, this lovely UI here in terms of, right, this is the name. You can enter an index name, and I'm going to do it here. You select a primary key. I'm going to select my reference because it's my unique identifier. Now my endpoint, I've already created this endpoint, and I'll nip out of this in a bit and show you how that's created. But again, it's very, very easy. Per workspace, you have a limit of 3 endpoints that you can create. Now I've got a couple of endpoints here. I'm going to choose an endpoint that I've already created. And here it's your embedding source, right? Now what it's expecting you to do is choose a particular column to embed. So it automatically recognizes from the data set that these are the columns that have got string variables, and I can select a particular column. Now, what I would have liked is for me not to select a particular column, for me just to throw in the Delta table and for it to embed the whole data set. However, text is unstructured. So if you're having to embed more than one column, what you can do is then concatenate several columns into a single column and embed the whole column.
Yeah, just jump it all together.
Yeah, just jump it. Yeah, exactly. And then here is a pretty cool thing as well. You've got your standard embedding models within Databricks that comes to default. But I've also hooked up the OpenAI Ada model for embedding. It's a pretty cool embedding model. And just to kind of show that you can do that, you can hook it up to OpenAI. There's loads of other models. If you're using Anthropic, for example, or Palm, there's flexibility in terms of what model you choose to embed your data set. I found this pretty cool, Sai. Sync mode. Perhaps you can teach me here. What's the difference between triggered and continuous mode? I guess it makes some sense in terms of continuous and triggered. Triggered seems to be a bit more manual, where you'll have to go and invoke a trigger functionality to update the table, and maybe continuous just does it automatically.
Making an entire guess. I'm going to assume it's using serverless behind the scenes because you needed serverless to be enabled. So I'm going to assume that one of them is just spinning something up and then charging you as a one-off, and you can choose I want to run hourly, run daily, because you want control over the costs that you're paying as to how many times it has to go and update that thing. Continuous, you might be paying lots of money because it's continuously coming in, but if it's only coming in like very sporadically, like maybe an update came in once a day, but it could be like anywhere in a 6-hour window, then that'd be quite nice because it would just trigger when it needs to trigger. So it's a bit of a mix as to, are you trying to predict when things are and automatically be checking even if nothing's happened? Or do you want it to just happen at the risk that if it constantly updated, you'd end up paying the cost for it?
Yeah.
Well, that's a guess. Cool. I don't actually know.
Okay. I think going back to the change data feed, having to enable that makes sense. Yeah. That makes sense, right? So
the other thing that's quite nice is, so Unity Catalog does have the idea of primary key columns. So you can flag something and say, this is the primary key. But these aren't plumbed into that. So when you had your primary key list, you could pick any column in there to act as the primary key. So you could be using a different key. So maybe you wanted to have 2 different indexes on the same table, you could have different keys used for it. So it's not forcing you to go down a route of going, this has to be the specified primary key in Unity Catalog, which is good.
Cool. And that's as easy as I've shown here. You just select a few things, select the columns that you want to embed, and you go on to create. And it does all the hard work behind the scenes for us. So what's that doing now? It's spinning up the demo index. As you can see, it's provisioning all the endpoints, the pipeline compute. It's ingesting the data, and it's going to say, right, I've done the embedding job for you. So go ahead. If you're going to try and embed this and do a RAG type question and answer bot, you can do that really easily. So what I wanted to show you now, I've done this before, as you can see. What you can also use is the SDK to create endpoints, to create a delta table, and do all the other things that I've just shown how to do it via the UI. What we can do here is do a similarity search now. So for example, here, I'm getting the vector index. I'm just doing a bit of a check to make sure that it looks all right. I'm just getting all this important information piped out as well. And here is where it's a cool thing, right? I have got reviews. By the looks of it, I've got a different data set that I'm showing. It's not chocolate anymore. It's fine food of Amazon here. But it's very similar. It's a similar concept in terms of, okay, I've got a huge data set and I want to search a certain key points. Go and look at the vector database, go and look at the document that's been embedded, and kind of bring out, I've stipulated 10 here. So you can stipulate any number that you want to see from the results. So here, what I've asked it to do is go and look at the dog food, spit out the product ID in summary, and give me the score as well for 10 of the closest ranking searches.
You've got to be very careful if you get dog food and chocolate mixed up. It's not going to work very well.
That is true. That is true. So it's pretty cool.
Very cool.
Yeah, and here, for example, here it even gives you the score in terms of how high it has scored. So if you've got dog food and if you're looking at a particular column, it's kind of taking it out and saying, right, this, for example, Econova adult small breed dog food, so it's not chocolate, scores a 0.67, which is pretty high.
So how often would you be using that index directly? Or how much would you always just have it as part of a workflow that's passing it into a large language model as part of a RAG implementation? Do you see many implementations of just the vector database on its own?
So I'm going to give you a very consultation-based answer. That depends on the use case that you're implementing. If you've got a knowledge base that you don't really see changing very much, then you just do the embedding once and you implement it into your RAG type pattern. If you've got a table like this, you've got reviews coming in every minute, every second, I don't know, then you would have that process being updated as frequently as you need to, for example.
Yeah, no, makes a lot of sense. Cool. All right. Anything else you wanted to show us in the wacky world of VSIs? VSIs, that's the cool trendy kids.
VSI, I do like that. Yeah. I mean, one of the interesting things that we've had a chat about is pricing. I know it's only preview, so it probably stands to change down the line. But in terms of the vector search pricing, that's the price in terms of monthly, roughly. If you're using 10 million vector count, using 5 units, depending on the region, you probably pay roughly from $1,000 to $1,300. So that's not too bad. That's comparable to other vector databases that we've used out there.
Yeah, and that's for 10 million. So that would be five lots of the 2 million capacity units.
That's it. Yeah, that's it.
Yeah, that makes sense.
Yeah.
So it's about $200 per capacity unit, and that gives you 2 million tokens that are saved in your embeddings. And as it says, storage is free during preview. Therefore, storage outside of preview, we will see.
Yeah, true. Yeah, so it's bound to change, right? Who knows? The other thing to note is there are some limitations. So if you want to understand what the limitations are, for example, per workspace, you're only allowed to spin up 3 vector search endpoints.
And that's 20 indexes per endpoint. Okay, yeah,
exactly.
Makes sense.
Yeah. Also, if you have a huge column of data sets, if you have more than 20, it's going to shout at you. But we've had this conversation before. Your racked up implementation pretty much depends on large text. You won't necessarily throw in a data set that's got more than 20 columns.
Yeah, you'd assume you'd have 5 or 6 indexing attributes, and then one column which is just a massive load of chunked up text, which is you're actually doing the embeddings on, is what we'd see most of the RAG star things for.
Exactly.
And I'm assuming you need to do that chunking yourself.
You have to do the preliminary chunking up. So if you've got a huge PDF document that's going to go over your token size, then you'd have to go through in terms of chunking it all up and then embedding it accordingly. That's right.
Cool. Yeah, makes sense.
So yeah, as simple as that. It's very, very easy now to get vector search going in Databricks. If you've got Unity Catalog, that gives you access to your entire documentation in your company and enterprise.
Awesome. I mean, I guess the only other thing people need to be aware of is the same serverless things, right? In that the serverless isn't working inside of your own Azure subscription. It's working inside the Databricks control plane, and you can do all the networking and private link and things to make it sure it's secure. So I assume you need to have that same consideration, especially if data is going to be stored outside of there on the serverless side of things. So you need to make sure it's fully networked up if you're going to use this stuff. And I've not looked at how that's working because it's just in public preview. So if you're trying to use this for real, full production use cases, make sure things are networked. It's the same advice for everything. Cool. All right. Well, thank you very much for joining us once again, Gavi.
No, thank you. I've enjoyed that.
Alrighty. So yeah, that is all we wanted to run through. Now inside of Unity Catalog, you can right-click on a Delta table. As long as it's got change feed enabled, you can then create a vector search index if you're in the right region, which is limited to, they're the first regions that we saw serverless go into. So it kind of makes sense. They're upgrading that first round of serverless ones, and then we'll see it proliferate to other ones, and then we'll see it go GA at some point. But yeah, definitely interesting. If you're trying to build that RAG style implementation, you want to build out real GenAI use cases where you're doing a bit of prompt engineering. You want to make sure it's accurate, not hallucinating, and all that good stuff. But you want to do it on your own data and actually have it in a continually updated way. You want to automate all that stuff inside of Databricks. That's what that's for, that you can now do it. So yeah, take a look. Have a run through the docs, have a run through the limitations. Make sure you're using Unity Catalog, because if you're not using it by now, you're starting to miss out on lots of the new features going into Databricks, so you should be using it regardless. And yeah, we'll catch you next time. Don't forget to like and subscribe. Cheers.